A, solving quadratic equations by factoring, specifically when a is equal to 1. Our objective for today is that I can solve quadratic equations by using the square root property, and I can solve quadratic equations by factoring. So what is the square root property? If you have a quadratic equation and there is no b term, you can solve the quadratic equation by taking the square root of each side. If the value is not a perfect square, you can leave it as a radical expression unless a decimal approximation is more appropriate. So let's take a look at letter A. We have something on the left squared is equal to 16. I can take the square root of both sides. And when I do that, I get x minus 2 is going to be equal to plus or minus, the square root of 16 is plus or minus 4. Okay? So now if we go back to when we worked with absolute value before and when we had pluses and minuses, we've dealt with square roots, we're going to break this apart. So x minus 2 is equal to the positive 4, or x minus 2 could equal the negative 4. Now we're going to solve for x. Add 2 to both sides on the left, x equals 6. Add 2 to both sides on the right, x equals negative 2. Right, so now this works when you have, in this case, we have a binomial squared. So this would be, if it's written in vertex form, you can solve using square root. Or if you just had an x squared term on the other side or an ax squared term, you'd be able to solve using square roots as well. All right, let's take a look at letter B. We've got x plus 5, the quantity squared, equals 21. So this is going to be one of those cases where when we take the square root, we are not going to be able to get a perfect square. So we're going to get x plus 5 is equal to plus or minus, the square root of 21 is 4.58 when we round it. So we split that into positive and negative versions. X plus 5 equals 4.58. X plus 5 equals negative 4.58. And then we subtract 5 from both sides. We get that x is equal to negative 0.417. We subtract 5 from both sides on the right, and we get x is equal to negative 9.58. All right, letter C, we have x minus 4, the quantity squared, equals 45. We take the square root of both sides, and we get x minus 4 is equal to plus or minus 6.71, which we split into two separate versions. X minus 4 equals 6.71 positive. X minus 4 equals 6.71 negative. And then we add 4 to both sides. X is going to equal 10.71, or when we add 4 to both sides, x is equal to negative 2.71. So this is one way of finding our roots, our intercepts of this quadratic equation. All right, so now we have letters D, E, and F. These are you-try problems. Please do those on your own and then come back and check your answers against mine. All right, letter D. We're going to start by taking the square root of both sides. And we get x plus 2 is equal to plus or minus, the square root of 36 is 6, which we can split into two possible equations. X plus 2 equals 6. X plus 2 equals negative 6. Subtract 2 from both sides. X equals 4. Subtract 2 from both sides. X equals negative 8. One of these two values could be the solution for it. Letter E. We take the square root of both sides. We get x plus 3 equals the square root of 28. Well, we're going to have to round that to 5.29, which we then, it's plus or minus. And now we split that. X plus 3 equals 5.29. x plus 3 equals negative 5.29. And we subtract 3 from both sides of both equations, and we get x is equal to 2.29. When we subtract 3 on the right-hand side, x is equal to negative 8.29. And letter F. We've got x plus 4, the quantity squared, equals 49. We take the square root of both sides. X plus 4 is equal to plus or minus 7. Split that. X plus 4 equals positive 7. X plus 4 equals negative 7. Subtract 4 from both sides. 7 minus 4 is 3. Subtract 4 from both sides. Negative 7 minus 4 is negative 11. And that's the square root property. Now, we're going to solve an equation by using the square root property. So our first example is during the egg drop competition at Annika's school, students must create a container for an egg that prevents the egg from breaking when dropped from a height of 30 feet. The formula h equals negative 16t squared plus 30 can be used to approximate the number of seconds it takes the container to reach the ground. Find the time it takes the container to reach the ground, round to the nearest hundredths place. So, height is going to be 0 because we want it to be when it hits the ground, right? So, reaches the ground. And we're finding what time is going to be there. So we substitute in 0 for height, and we've got negative 16t squared plus 30. So how do we go about solving this? We don't have it equal to each other again. Well, let's start by subtracting 30 from both sides. 0 minus 30 is negative 30 equals negative 16t squared. Now, our next step in isolating the variable, we need to get rid of that multiplication, so we're going to divide by negative 16. And when we do that, we get negative 30 over negative 16 is 1.875 is equal to t squared. And now we take the square root of both sides, and you get plus or minus 1.37 equals t. So this is a time where now we have to interpret what is the reasonable solution given the scenario. The scenario is that we're talking about the time it takes for it to reach the ground. So does the negative value make sense? It doesn't really. So we're just going to say it's 1.37 seconds. It doesn't make sense for it to be a negative value because that would be negative time, and that just doesn't work. All right, so letter B. Every year, Vincennes, Indiana hosts a watermelon drop on New Year's Eve. An 18-foot-long wooden watermelon is lifted into the air by a crane. At midnight, the wooden watermelon opens and drops actual watermelons onto a platform where they burst open and the crowd cheers. Because let's be real, who isn't entertained by, giant fruit falling from the sky? The formula h equals negative 16t squared plus 84 can be used to approximate the number of seconds t it takes for the container to reach the ground when dropped from a height of 84 feet. Find the time that it takes the watermelons to reach the ground, round to the nearest hundredths place. All right. Well, first off, there's a picture of the giant watermelon in 2020 that's going to drop other watermelons. But we have our formula. 0 is equal to negative 16t squared plus 84. So we're going to subtract 84 from both sides because we're trying to get that 16t squared by itself. So we have negative 84 equals negative 16t squared. Divide by negative 16. And when we divide by negative 16, we get 5.25 equals t squared. And we take the square root of that, and we get plus or minus 2.29 seconds, but it's just going to be 2.29 seconds. The negative one doesn't make sense because we're not going backwards in time. We're just starting from the moment they release it we're counting forwards until it goes splat, and that would be approximately 2.29 seconds until you get that splat. And Gallagher would approve. If you don't know what Gallagher is, he was a comedian from the 80s that would famously smash a watermelon with a giant sledgehammer. Go look him up on YouTube. All right, example 3 is solving a quadratic equation using the zero product property. What is the zero product property? It states that if the product of two factors is 0, then at least one of the factors must be 0. For any real numbers, a or b, if a times b is equal to 0, then a is equal to 0, b equals to 0, or both a and b equal 0. So let's kind of work our way through this and see what we need to do here. So the first one, we're already factored. We've already factored, and it's x times x plus 1. So what you're going to do with the zero product property is you're going to take this first piece and set it equal to 0. You're going to take the second piece and set it equal to 0. And then you solve for your variable. Well, the first one, x equals 0, we've already solved for x. We need to subtract 11 from the second one, and x equals negative 11. So your two roots for this equation are x equals 0 and x equals negative 11. Those are your two solutions for letter A. Letter B is also already solved for or factored for us. So we have x minus 5 equals 0, right? Because one term could equal 0. The other term could equal 0. X plus 9 equals 0. Or they both could. And now we need to solve each one of them independently and find our two values. So x minus 5 equals 0. We add 5 to both sides. X equals 5. X plus 9 equals 0 is we subtract 9 from both sides, and x equals negative 9. All right, what about 16? What's going on here? Well, we got x squared minus 16. That looks suspiciously like the difference of two squares. So can we factor this? Yes, we can. X minus 4, x plus 4. Now, can we split that into two pieces? X minus 4 equals 0. X plus 4 equals 0. And then we add 4 to this one. So x equals positive 4. We subtract 4. X equals negative 4. Now, you might be looking at that and saying, well, Mr. Boland, you could just say x squared equals 16 and then take the square root of both sides and you get x equals plus or minus 4. Well, yeah, you could do that, but factoring is more fun. Recognizing special cases is more fun. So that's one where you could do two different methods to get to the end result. Either way, you're going to get to the same result that you have plus or minus 4. So you could factor, or you could use the square root method in that particular case because there's no b term. All right, let's look at letter D. Now, letter D, we don't have factored already. So we're going to have to do the factoring ourselves. And I don't see a trinomial here, so I'm not going to get two binomials out of it. But what do I see here? There's a thing that we need to look for first all the time that we always forget to look for. Now that I've given you a second to think about it, what are we looking for? We're looking for a greatest common factor that we can remove. So x squared minus 7x, a common factor is x, and what am I left with? X minus 7. I'm going to put a big star next to this because you're going to see a question similar to this on the quiz, where you're going to have to factor something out and remember that it's one of your factors as well. So you have x equals 0, x minus 7 equals 0, x equals 0, there's nothing else to do there. X could be 0. 0 could be one of our values that gives us a solution. We add 7 to both sides on the second one, and x equals 7. So you have two possible solutions here. X equals 0, x equals 7. All right, letter E. We're going to actually have to factor this one. So I'm looking for what are my factors of 18 that add up to 9. Well, factors of 18, you've got 1 and 18. that adds up to 19. You've got 2 and 9, that adds up to 11. You've got 3 and 6, that adds up to 18. Or sorry, that adds up to 9 and multiplies. So x plus 3, x plus 6 equals 0. So if your factoring skills are rusty from a couple units ago, you need to go and do some practice on factoring. So we have x plus 3 equals 0, x plus 6 equals 0. What would make each of these pieces 0? So we subtract 3 from both sides. X equals negative 3. We subtract 6 from both sides. X equals negative 6. If we were to graph this, negative 3 and negative 6 are going to be our x-intercepts. In fact, I think we did graph this one at one point in time. All right, letter F. We're not in standard form because we're not equal to 0 right now. So I need to start by adding 49 to both sides. We need this to be equal to 0. So we have x squared plus 14x plus 49 equals 0. So now, when I look at this, I see 49 is a perfect square. X squared is a perfect square. Where do I remember something about a special case where we have a perfect square for the first and last terms? We could check to see if it's a perfect square trinomial. Is our middle term twice the first two square roots? Well, let's see. If we've got x and 7, x times 7 is 7x times 2 is 14x. Hey, look. Factors of 49 that add up to 14 are 7 times 7, because 7 plus 7 is 14. So that is x plus 7 squared is equal to 0. So do I need to list this twice? Do I need to list x plus 7 equals 0 and then x plus 7 equals 0? No, that's foolishness. You just need to list it once because there's only one solution for this. You subtract 7 from both sides and x equals negative 7. That's your answer. And we don't need to worry about that. So as we've looked at these, so far we have seen things that have two solutions and things that have one solution. So in the case of letter F, we know that our vertex is at negative 7, 0. We're moving this one 7 to the right. And if we look at vertex form, 7 to the left, if we look at vertex form, it's right there. X plus 7, the quantity squared. We're moving that to the left 7 and not up or down at all. So your solution is at negative 7, 0. So that's kind of that bridge from what we saw when we were graphing to now what we're seeing calculating. All right, there are 6 U-try problems that I would like you to do on your own and then check your answers against mine. All right, letter G. We have x squared minus 7x plus 12. We're looking for factors of negative 7 that add up, factors of 12 that add up to negative 7. So both of them need to be negative because they need to multiply to a positive. So we're going to get x minus 3, x minus 4 equals 0. And we split them. X minus 3 equals 0. X minus 4 equals 0. Add 3 to both sides. X equals 3. Add 4 to both sides. X equals 4. Letter H. We have one set up for us. This is the exact same thing that we had just above. X plus 7 times x plus 7 equals 0. X plus 7 equals 0, minus 7, x equals negative 7. So this one was already set up for us. Letter I, we're going to start. We don't have a trinomial here, but there is a greatest common factor we can take out, and it is 4x. And we're left with x minus 3. That's all equal to 0. So now we split that into two setups, two equations. 4x equals 0, or x minus 3 equals 0. Divide by 4, x equals 0. Add 3, x equals 3. Those are my two solutions there, 0 and 3. Letter J, x squared minus 2x minus 35 is equal to 0. We're looking for factors of negative 35 that add up to negative 2. So I know one needs to be positive, one needs to be negative, and the negative needs to be the greater magnitude because it's the one in control. So we have x minus 7, x plus 5 equals 0. So we have x minus 7 equals 0. X plus 5 equals 0, right? Zero product property, one or both of those could be 0. So instead of subtracting 7, we add 7, so x could equal 7. We subtract 5 from both sides, x equals negative 5. Now, why do I say it could be? Well, because you need to look at context. Depending on the context of the situation, a positive answer could be more appropriate. A negative answer could be more appropriate. Both answers could be appropriate. It all depends on the context of the situation that you're given. And when you're just given a naked equation, you don't have that context, so you're going to list them both. Letter K, x squared minus 12x plus 36 is equal to 0. So I'm looking for factors of 36 that add up to negative 12. This is one of our special cases because it's a perfect square trinomial. So we have x minus 6, x minus 6 equals 0. And so when I set that up, x minus 6 is equal to 0, and then I add 6 to both sides, and x is equal to positive 6. And again, if we wrote this in vertex form, x minus 6 squared equals 0, we're moving it 6 to the right. And that's our y-intercept. It's also our vertex. All right, letter L, final problem for the day. This, I'm going to put a star next to this because this is the kind of question that I would give you on a quiz because I'm mean like that. But I want you to know that first you need to set this equal to 0. So we're adding 3x to both sides. So we've got 8x squared plus 3x equals 0. Then I'm going to look at the fact that I have a GCF here that I can remove. And so I bring out an x, and I'm left with 8x plus 3 equals 0. And now we split it into two equations. X equals 0, 8x plus 3 equals 0. Now, this is the first time that we're having an a term, essentially, that isn't going to be 1, even though I said a terms were going to be 1. That was mainly for the regular factoring that we're going to do. Finding a GCF is not one of those cases. But now we've got more going on here. So it's not just as simple as adding or subtracting. So we're going to subtract 3 from both sides. We get 8x equals negative 3. And then our final step is to divide by 8. And we're just going to leave that as x is equal to negative 3 over 8. You do not need to write this as a decimal at all. You can just write it and leave it as the fraction. Fractions are our friends. If you really, really, really don't like fractions and you really like decimals, negative 0.375 would be an acceptable answer. There is in no time going to be an expectation that you give me the decimal answer versus the fraction. I would actually prefer fractions. This one isn't too bad since it is a terminating decimal. I especially like to keep things fractions if it is a repeating decimal because it keeps it as a more precise answer than when you round it off. Okay, so that is our notes for today. That is the end of lesson 11.4a, solving by factoring with a equals 1. We can certainly be taking a look at, we will certainly be looking at more advanced factoring tomorrow, but for right now, this is just where we're at. We're just focusing on a terms of 1 and using the zero product property. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.